Okay. Uh, Hello, everyone. My name is Sadia Siddiqa Binte Roshid, and today I'm going to approach for criteria evaluation, software development perspective, and integrated approach for criteria evaluation and software maintenance process management insights from global software development perspective. This is my paper title actually. So today the agenda of this paper analysis is the paper's background, research gap and problem statement, research objectives, scope and contribution, methodology, which is the phase 1 and 2, another one is implementation steps, and then which is about results and discussion, and the last one is conclusion and future work. So the very first is about the background. So global software development, or GSD, is now for 60 to 70% of total lifecycle cost, organizes expenses actually. Organizations adopt offshoring strategies to reduce cost and access global talent. Offshoring maintenance involves technical, managerial, and human factors. Improper evaluation of these factors leads to risk, delay, and quality issues. Decision making becomes complex due to intradependencies among criteria. Therefore, a structured and multi-criteria decision support approach is required. So this is all about background. Okay, the next slide is about the problem statement and research gap. So the problem statement of the paper is software maintenance offshoring decisions are complex and multi-dimensions. Means the decisions of software maintenance things is very complex and multidimensional. Decisions involve technical, human, managerial, and legal factors. All includes about this. Most organizations rely on experience-based or ad hoc decision making. As it's more difficult, they depend on experience things. Interdependencies among factors are often ignored. Poor evaluation leads to cost overrun, communication failure, and quality issues. Lack of a structured decision support mechanism for maintenance offshoring. So the research gap is existing studies focused on isolated factors, not their interrelationships. Limited use of ISM to model hierarchical relationships in maintaining offshoring. Few studies integrates ISM with MCDM techniques. The lack of combined AHP TOPSIS framework for sourcing model selection. Insufficient practical decision support models for industry use. Limited empirical validation in global software development context. So these are the points of research gap of this paper. The next slide is about research objectives, what is the objective of this research paper. So here are the points: to identify key factors influencing software maintenance offshoring in GSD, to analyze interrelationships among factors using ISM approach, to classify factors based on driving and dependence power (MCMAC), to determine criteria weights using analytic hierarchy process AHP, to rank sourcing alternatives using TOPSIS technique, to develop an integrated decision support framework for practitioners. Okay, then the next slide is about scope of the study and contribution of this research paper in the field, in the world. Okay. So the scope of the studies focuses on software maintenance offshoring in global software development, considers technical, managerial, and human-related factors, limited to key influencing factors identified from literature and expert opinion, applies ISM to analyze factor interrelationships, uses AHP and TOPSIS for sourcing alternative evaluation, applicable to offshore, nearshore, and onshore sourcing model. Okay, so these are the scope of the study, and next one is contribution of this research paper. Identifies and validates critical factors for maintenance offshoring decisions, proposes on ISM-based hierarchical model showing factor interdependencies, classifies factors using MCMAC analysis, develops an integrated ISM AHP TOPSIS decision support framework, provides a practical decision-making tool for industry practitioners, enhances understanding of structured sourcing selection. So here we can see that they have talked about ISM AHP TOPSIS framework. So what is this? It works by first using ISM to understand relationships between criteria and filter them. The framework is a powerful multi-criteria decision-making MCDM approach that integrates interpretive structural modeling, analytic hierarchy process, and technical for order preference by similarity to ideal solution to solve complex problems like supplier selection or sustainability evaluation. That is about ISM HP TOPSIS framework. So it works by first using ISM to understand relationships between criteria and filter them, then using HP to weigh the remaining criteria through expert input, and finally using TOPSIS to rank alternatives based on their proximity to ideal and non-ideal solution. Okay, the next slide is about methodology, phase 1 and 2. So in phase 1, they have talked about requirements and planning, stakeholder analysis, feasibility study, communication strategy, risk assessment, which is all is in phase 1. In phase 2, they have talked about global architecture design, which is component modularity, breaking the system into dependent modules for distributed teams. Interface standards, defining how globally developed parts still interact. Tech stack selection, finalizing universal frameworks and languages. Data security design, ensuring compliance with international data laws. So this is about methodology, which is phase 1 and 2. In methodology implementation steps, they have talked about step 1, which is distributed coding. Step 2 is integration and testing, which is step 3 is global deployment, and step 4 is about maintenance and support. So step 1, which is distributed coding, which is version control and coding standards. Then in integration and testing, they have talked about continuous integration and automated testing. And in step 3, global deployment, which is about cloud hosting and localization. In step 4, they have talked about maintenance and support, which is follow the sun model, which is means 24 by 7 hour support using teams in different time zones. Performance monitoring means real-time tracking of global server health. So in the next slide, we can see this is a picture of adopted research methodology. They have combined some phases and approaches. So we can see this is phase 1 and this is phase 2. Phase 1 is analyzing the report factors, merging similar factors, identifying a list of 10 factors, and factor 2 is about online survey, ISP, HM, and TOPSIS implementation. This is all combined. And after the phase 2, they have employing HEP and TOPSIS techniques. Okay, so this is about adopted research methodology. So how this ISP and HP TOPSIS decision support framework works, integrates structural analysis and multi-criteria decision making. ISM identify hierarchical structure and interdependencies among factors. MICMAC classifies factors based on driving and dependence power. HP calculates relative importance of decision criteria. Consistency check ensures reliability of expert judgment. TOPSIS evaluates and ranks sourcing alternatives. Selects alternative closest to the ideal solution. Provides a systematic, transparent, and practical decision support tool. So in the next slide, this is results and data analysis, which is about key factors identification, which is ISM approach, and then quantitative analysis, which is about HP and Lambda Max, So in key factors, they have talked about some top level success factors, which is cost saving, infrastructure, domain knowledge, project management, and requirement changes. Okay, these are the top level factors they have talked about in results and data analysis. The model was implemented based on responses from 15 industry experts via online questionnaires. Means from online survey, they have take data from 15 industry experts in this paper. And the quantitative analysis is the calculation of lambda max value, which is 11.048, ensures the consistency of the decision making process. Okay, they have this is pairwise comparison matrix. So in the 3 number points, they have comparative analysis of alternative strategic selection, which is offshore performance, onshore performance, and nearshore performance. These three GSD models, they have the do the comparative analysis. Okay, so in highest value, which is uh, mainly offshore actually, which is 0.811, and so onshore showed the better control actually. Huh? And the factor evaluation infrastructure onshore and offshore models both showing strong, means onshore and offshore models both showed strong infrastructure support, which is 0.625. Project management offshore is 0.118, outperform onshore in scale project management effectiveness according to the matrix. So we can see that if we rank this model, the final ranking, if we do according to top six, so the rank 1 model is offshore, and the rank 3 is onshore, and the middle rank means rank 2 is nearshore, which is according to top 6 model. Rank 1 is rank 1 is offshore, and rank 3 is onshore, rank 2 is nearshore. So in conclusion, we can tell that the integrated ISM HP TOPSIS framework provided a robust decision support system, assist experts in evaluating and selecting effective source strategies, successfully identifies and models strategic interrelationships among key factors, helps organizations optimize time and resource constraints, offers strong academic and industrial value through structured factor analysis, supports effective sourcing decisions in global software development. So the future work we can do with more on this topic, which is extend the framework by incorporating additional influencing factors, conduct in-depth industry-based investigation, which is means we can do the field work, enhance the ISM-based model to handle complex and dynamic sourcing environments, explore integration with advanced decision-making techniques. So this is all about from my side. Thank you.